Hello again, ladies and gentlemen. All right, so today we're going to move on from congruent triangles to similar triangles. Okay, so I have these notes, okay, and a lot of what I'm going to say is written here already, okay, until we get to the actual examples. But so we have triangle similarity. Now it's only going to be angle, angle, okay, because two triangles will be similar if two angles of one triangle are congruent to two angles of the other. Okay, so that's really all that you need to prove. Okay, remember, triangles are similar if all the angles of one are congruent to all the angles of the other. Okay, but in order to prove it, we're only going to have to show two pairs congruent, all right, because you've heard me say it many times before. If two angles of one triangle are congruent to two angles of the other, the third one has to be congruent. So there's no need to show that third angle. Okay, so it's actually going to be easier to prove triangles similar than it was to prove them congruent because you just need two angles. You don't need to prove any sides. Okay, but unfortunately, it's not that simple. Okay, there are three different ways that a similar triangle proof can be presented to you. Okay, three different things you can be asked to prove. Okay, so the prove statement can look three different ways. First, prove the triangles are similar. That's the easy one. Okay, two angles and you're done. All right, prove that a proportion is true. Okay, we're going to see examples of all three of these, but remember, corresponding sides of similar triangles are in proportion. So in a case like that, they give you the proportion and ask you to prove the proportion. All right, and the third one, the cross product is true. You know that when you have a proportion, the way we solve it is we cross multiply. So the products diagonally are equal to each other. Okay, so we're going to see each one of those proof statements, and I'm going to show you how to handle each one of them. Okay, so we're going to take these one at a time. Okay, so I have this diagram. It's kind of a complex looking diagram, but you'll notice the first given, PQRS, is a parallelogram. Now tomorrow I'm going to be talking about proofs where you're given that it's a parallelogram. So this is just kind of like a preview of that. Okay, we're going to talk a little bit more about that tomorrow, but also RSC is a straight line. Okay, so that's the other given. Okay, so now each of these proof statements, I've got three of them, okay, are pairs of triangles within this diagram. Just like some of the other diagrams we saw, there's multiple triangles here, multiple pairs, okay, and part of this lesson is going to be how to spot which triangles you need to be focused on. Okay, so this first example is going to be the easiest of those three proof statements where you're just trying to prove the triangle similar. So I'm telling you which triangles in this case. Okay, so since I have three proof statements and one given, I'm going to write all of this all in the same proof. Okay, as soon as we're finished with part one, I'm going to keep moving on to part two and then part three of this. Okay, I'm not going to start over. I'm not going to restate the givens. I'm just going to continue and make it all one proof. Okay, so and along the way, we're going to talk about what information you get from the fact that PQRS is a parallelogram and how to state certain things, okay, and how to use that information. All right, so what you're going to need to open up is your pathways for success in proofs. And here's the pathway to success for proofs, and we're going to be talking about this section of it right here, okay, that deals with parallel lines, corresponding angles, and alternate tier angles, etc. So getting back to this. Okay, so PQRS is a parallelogram, so I'll start there. Okay, PQRS, a parallelogram. Okay, so for part one, we're trying to prove RQB, that's this triangle, similar to this triangle. Okay, oh, by the way, notice the symbol for similar is just that tilde. It's not the congruent symbol, it's the tilde. That says similar. Okay, so just be aware of that that's the new symbol that we're going to be using, and you have to be careful which symbol you use. Okay, when you're doing these. All right, so we have those two triangles that we're trying to prove. Now, the fact that PQRS is a parallelogram tells us a bunch of things. All right, well, clearly we can get these two angles congruent to each other by vertical angles. Okay, so we have those. Now we need another pair. Okay, but what this tells us that PQRS is a parallelogram is that RQ is parallel to SP. Okay, and when those are parallel and cut by a transversal, namely RP or QA, those are two transversals, okay, they form congruent alternate interior angles. Okay, so this will be worded similarly to the vertical angles reason. Okay, so you'll see that when we get to it, but that's what we're going to do. So we're going to say this angle here, okay, is congruent to this one, and we could say this one is congruent to that one, okay, by using alternate interiors. Okay, so I'm going to eliminate all those marks, and we're going to see how to write this thing. Okay, so if you're going to use parallel lines cut by a transversal, you need to state which lines are parallel to each other. Okay, so in this case, I want to say RQ is parallel to SP. Okay, now that, since this is a parallelogram, and a parallelogram is a quadrilateral with two pairs of parallel sides, by definition, okay, I can say that is by definition of parallelogram. Okay, definition of parallelogram. Okay, now I'm going to number some of my angles to make this a little bit easier to deal with. I'm going to call this one 1, this one 2, this one 3, and this one 4. Okay, so I can say angle 1 is congruent to angle 2. I can also say angle 3 is congruent to angle 4. And my reason is, again, it's going to be worded similarly to the vertical angles, and I have to say parallel lines cut by a transversal form congruent alternate interior angles. Okay, and now if I were writing this proof, that would be enough. I've got two pairs of one congruent to two pairs of the other. I could say that the two triangles are similar. Okay, or I could have said the angles, the two vertical angles there are congruent also, and that would have been a third angle, a third option. Okay, but I wanted to show you what the wording should look like if you're going to use parallel lines cut by a transversal, alternate interior angles. Okay, so now we can say triangle, okay, RQB is similar now, not congruent, but it is similar to PAB. Okay, and we showed that using angle, angle, congruent to angle, angle. Okay, so that's one pair of triangles similar. Okay, now look at part 2 here. CSA, okay, congruent to CRQ. So CSA is this triangle here, all right, congruent to CRQ, which is this big triangle here. Okay, so now I'm going to use a different type of pair from the parallel lines. I've already stated RQ and SP are parallel up above in step 2. Okay, but now I can use this angle is congruent to this angle. Okay, and this one is congruent to this one. Okay, what kind of angles are those? Okay, parallel lines cut by a transversal form congruent corresponding angles. Okay, so that's what we're going to do for those. And then, of course, we have angle C, which is part of both of those. We can use angle C is reflexive. Angle C is congruent to angle C by reflexive. Okay, so that's another way we can get one of the angles. But at least one of the angles used has to be corresponding in this case. Okay, so that's what we're going to do next. Okay, so, all right, so just to make my life a little bit easier, I'm going to call this angle 1, I'll call this angle 2, I'm going to call this angle 3, and this angle 4. Okay, so that will make my life a little bit easier when I'm typing this thing. All right, so I'm going to say angle 1 is congruent to angle 2. Okay, I'm still using congruent because the angles themselves are congruent. The triangles are similar, but the angles themselves are congruent. Okay, so the second thing I can say here is angle 3 is congruent to angle 4. Okay, and the reason for that, okay, looks just like number 3. Parallel lines cut by transversal form congruent. In this case, it's corresponding angles. So again, at that point, I'm finished. I've proven 2 angles of one congruent to 2 angles of the other. Okay, so the triangles are similar, but just for good measure, I'm going to add in here angle C congruent to angle C. All right, just to show you that that is also another option for one of the angles. Okay, and that's reflexive. Okay, so now I can say triangle CSA is similar, okay, not congruent, but we prove them similar, so be careful about what you write, similar to CRQ. Okay, and again, we did that by angle, congruent to angle. We showed the angles are congruent, the triangles are similar, so make sure you're using the right symbol, or in this case, the right word when we're typing them in on Kami. Okay, when you're writing them, handwriting them, you can use the congruent symbol and the similar symbol. Okay. Okay, so now we can move on to the third pair here. RQP and PSR. Okay, RQP, that's this one, is congruent to this one. Okay, now you might look at that and say, well, aren't those congruent to each other? And they're going to end up being congruent to each other, yes. But if 2 triangles are congruent, okay, that's going to mean all of the angles are congruent to each other. That means they're also going to be similar. Okay, so if they're congruent, they're similar. Okay, it doesn't go the other way, though. If they're similar, it doesn't necessarily mean they're congruent. Okay, but we're trying to prove them similar now. Okay, so that's what we're going to do. Okay, so for these triangles, okay, I can do this. All right, I can say, I'm going to call this angle 1, and I'm going to call this angle 2. Okay, and I can say angle 1 is congruent to angle 2 because, again, this is now a property of the parallelogram. Okay, opposite angles of a parallelogram are congruent. Okay, so again, the only reason I'm showing you all 3 of these different sets of triangle similars so I can show you the different ways that you can get the angles when there's a parallelogram. When you've got parallel lines, when you've got a parallelogram, you're using the properties of parallelograms. We're going to talk more about that tomorrow, but that is one angle that you can use. Angle 1 is congruent to angle 2. Okay, so now I need another angle within those 2 triangles. I'm going to focus on these 2 now. This one and this one. Okay, I'm going to call them 3 and 4. Okay, because now those are going to be alternate interior angles, but they use the other 2 pairs of parallel sides. Okay, so in order for me to focus on those 2, I need to actually state the correct pair of sides parallel. I've only stated RQ and SP. Okay, so those are not alternate interior with those 2 sides. Okay, I have to state that SR is parallel to PQ. SR is parallel to PQ. Okay, and that is because, again, hey, that's by definition of parallelogram. And now that I've stated those 2 parallel sides, now I can say angle 3 is congruent to angle 4. And again, for the same reason as 3. Okay, parallel lines cut by transversal form congruent alternate interior angles. Okay, now I could have stated these angles, let's call them 5 and 6. Okay, I could have stated those were congruent to each other, again, by alternate interior, and I had already stated those parallel sides. All right, again, I'm just showing you all of your different options for these. Okay, so I have more steps than I need here. Okay, but I wanted to just kind of show you how things are used within this diagram. Okay, so now that's it. So that's the last one. So we've proven triangle RQP similar, okay, to PSR. Okay, and we did that again. The only way we really can prove similarity is AA congruent to AA. Okay, so I'm going to cut this video here, and we're going to go on to parts 2 and 3 in different videos. All right, so we'll see you next time.